what we want to do is actually come up with making the actual trig equation. So I've got this boxed in. In fact, I'll highlight it. This is kind of like the equation, the standard form of any trig graph. Now what we're going to be doing is just sines and cosines, okay? We're going to be doing sines and cosines. And what does all this mean? So A stands for the amplitude, and the amplitude is how high a graph goes, the height going up and then down. B is called the frequency. With frequency, though, in order to figure out what B is, in order to find out what B is, it's just going to be the normal 2 pi, which is the normal width of a curve divided by its curve width, and that'll give you the value of B. To get the amplitude, if you have a difficult time getting the amplitude, it's just the maximum of the graph minus its minimum divided by 2. So if you can't see it, we can just use an equation to get the answer, okay? H is a horizontal shift, and of course with the negative it's just the opposite, right? Either shift it positive to the right or negative to the left, right? But it all depends on the opposite direction, right? And then finally K is a vertical shift either up or down. So let's take a look. So example 1, first of all, let's graph example 1. Let's do what we've been doing. And then when we get to example 2 and 3, we're actually going to come up with and make equations. We get to the back, 4 and 5. Again, we're going to make the actual equations. So let's start first of all right at the bat. So example 1 has several steps to it. It really does. So what I'm going to do is I'm going to do it in 2 steps. The first part I'm going to graph, and I'll put it in pencil so that I can move it. But the first part I'm going to graph is just this piece here. I want to do all of my horizontal and my vertical shift second. So I'm going to graph first just the y equals the -3 cosine of 2x. So I need to know what a general cosine graph looks like, okay? So I'm going to put 2 graphs on the side here. The general shape of a sine curve looks like this. The sine curve starts at the origin, okay? That's sine of x. And the other, the cosine, starts at the top. Think about a roller coaster. Here's what I tell kids. If you're going to get on the roller coaster at ground level, then that's a sine curve, okay? The roller coaster, though, for a cosine curve, you'd have to walk up to the top, and the roller coaster starts at. They have the same shape, but it's where you start. This is the cosine, and that's the sine. So what we need to do on our first example is we need to take this shape. It's going to go from 3 to -3, and it's going to be upside down. Okay, so first of all, let's at least do that. Let's go our 1, 2, 3. Go our 1, 2, 3. All right. I also need to know something about the period of this. So the period of this graph, how wide it is it's normal 2 pi, but divided by its frequency. So we take the normal 2 pi and divide it by its frequency. So the new period, how wide the graph is of this particular graph, is going to be pi. Has to be, because in order to fit 2 curves within the normal 2 pi, each curve's got to be pi wide. So I know I'm going to have axes that deal with pi, so I'll take care of it. I'll go pi halves here. I'll go pi, 3 pi halves, and 2 pi. So now, once I have my axes figured out, my y-axis, my x-axis, I'm going to try and fit this shape between 0 and pi, okay? And what I need to do is make sure that it's going to be upside down, so it's going to be upside down because of the negative, and I make sure it goes from -3 to 3. So this shape's going to be upside down because of the negative. It's going to go from 3 to -3. So this shape is going to end, it's going to begin at -3, and it's going to end at -3. So I want this shape basically is going to look something like this, okay? Halfway through, it's going to be up at +3. Its x-intercepts are 1/4 of the way through and 3/4 of the way through. So one curve will look like this. All right? And I'm going to repeat that pattern because I need 2 of them. That's what the frequency means. I need 2 of them. So to the same shape again, it starts at -3. It's going to end down at -3. Halfway through, it's going to have its maximum up at +3. Its x-intercepts are here and here. So I'm just going to get the second shape. So I'm not done, but I have part of it done. I've got two curves, which I needed, within 0 and 2 pi. It's upside down because of the negative, so it is upside down cosine curve, and it goes from negative 3 to 3. Okay, so far so good. Now the second part I do to do this is I'm going to move it. I'm going to move it back pi force. I'm going to move it up 1. Okay, and I'm going to do that in my fuchsia so we can see the actual answer. Okay, so what I consider every important point, those are your max, your mins, and your x-intercepts. Those are the important points to move. You can't move all of it, but if we move all of those points, then we can get it. Okay, so let's go back pi force. Pi force happens to be 2 squares in my graph, because if that's pi halves, then that's pi force. So pi force is really moving it 2 squares back and then 1 square up. So every point's going to go back pi force, up 1. We're going to go back pi force, up 1. We're going to go back pi force, up 1. Back pi force, up 1, 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 back pi force, and up 1. Okay, and then we just have to draw it in. And there it is. Not bad. We've done this. Okay. And of course, Ryan showed you how you can do it on the calculator also, but I think sometimes it's easier just to do it by hand, okay? Now, example 2. Calculator is not going to help you in example 2 at all. Because we've got the graph, we need to come up with the equation. So here's how it works. Let's take a look at what we have up here, okay? We want to go ahead and find the amplitude. We need to figure out if it's a sine or a cosine. We need to find out what the frequency is. We need to see if there's a horizontal shift, and we need to see if there's a vertical shift. So here's where I start. I start right off the bat on these, asking myself, is it a sine or a cosine curve? That's the first question. Sine or cosine? It's a sine. Do you see it starts at 0, 0? It's definitely a sine. So let's start right here. Let's go y equals sine. Just leave it there. Y equals sine. That's the first thing. Is it a sine or cosine? It's got to be a sine because it starts at 0, 0. And then the roller coaster goes up and comes back down, okay? If it was a cosine, we'd be starting at the height and then rolling down, okay? Right? So now it is a sine curve. So the next thing I figure out is the amplitude, okay? The amplitude is up 3, down 3. 1, 2, 3, down 3. Now if you can't see the amplitude, the little formula says, okay, it's max, which is 3, minus min, which is a negative 3, divided by 2, right? Max, which is 3, minimum's a negative 3, so 3 minus a minus 3, divided by 2, which is 6 over 2, which is, sure enough, 3. But we can see this one. This one's not too hard. So I'm going to put a 3 right here. It's not upside down, so I wouldn't put a negative. It just starts up like a normal sine curve would. Now, after I get the amplitude, I need to find the frequency. Okay, so I need to find B. Well, according to my little rule here, B is 2 pi, because that's the normal period, and then I'm going to go ahead and divide it by the period of this one to find out what the frequency is. So let's take 2 pi, my little formula says 2 pi, divided by the curve width. So what is the curve width? Well, if you took a journey, one full journey on the roller coaster, you're going to go up, roll down, and back to the beginning. Okay, so that's one full cycle of this curve. Okay, so how wide is that? That's just 4, right? So the width, the curve width is just 4. So the frequency is going to be pi halves. Okay, the frequency B is going to be pi halves because I reduce that. 2 pi over 4 is pi halves. So I'll put pi halves right there. Okay, parentheses. Okay, I'm just following this formula right here. Following this formula, I've got my frequency, parentheses x. Now, the sine curve has not been horizontally shifted. It started right at the origin, which is exactly where it is. So really, there's no horizontal shift. I could put a minus 0 in there, but it's kind of a waste of time. So there is no horizontal shift, right? Now, same thing, there's no vertical shift. I mean, it started 0, 0 like it should. It didn't get moved up. It didn't get moved down. So I could put a plus 0, but I don't need it. So this is the equation for example 2. Now, here's the thing about trig. We could have also called it a cosine curve if we wanted to. We're not. But somebody could say, well, I want to start there and call it a cosine curve. Then we would have had a horizontal shift. That's the reason in science we only call waves sine waves, because every cosine curve could be made into a sine curve. All right? We'll keep talking about that. Okay, example 3. All right, let's take a look at it. So, example 3 is interesting because you have several ways to call this. You could either call it a sine curve and start here. You watching? I could call it an upside down cosine curve, negative cosine curve, and start here. I could start here and call it a negative sine curve. I could start here and call it a cosine curve. Doesn't really matter. For me, well, actually, I'll ask you. What do you want to call it, a sine or a cosine? Take a look at the two shapes. Do you want to call it a negative cosine then?
Yeah, negative cosine. What about the actual cosine?
Okay, so you're going to call it a cosine, actual cosine, then you'd have to start here, which is okay. If you want to call it an actual cosine, because cosine starts at the top, right? So if you move your axes here, you can call it a cosine. Or you can call it a negative cosine and start here. If you call it a negative cosine, then there's no horizontal shift.
Do that.
Yeah, let's start here. Let's call it a negative cosine. That's what I would do. So, I mean, really, what we're looking at is a curve that would go like this, right? You okay with that? Not very well done, but you know, you got the idea. So let's go y equal, and let's call it a negative cosine. Now a little space there because I need an amplitude, okay? Great. Amplitude. Okay, what do you think the amplitude is? 2, everybody agree? 2, it goes down to 2. Goes up to 2, so we'll put a 2 here, okay? Now B, which is our frequency. To find B, the little note says 2 pi divided by the curve width. So I'm going to go 2 pi divided by the curve width. So how wide is this curve? Well, I could journey from here at negative 2 pi to 2 pi. So the width of this curve
4 pi.
is 4 pi. Yes. The width of this curve is 4 pi, so I could journey from here to here. It doesn't matter where you get on the roller coaster. One full ride could start from here to here, right? One full ride could go from here to here, but either way, the width of that curve or that ride is going to stay the same. It's going to be 4 pi, which reduces to 1/2. So B is 1/2. Not 1/2 pi, because the pi's cancel, right? Just 1/2. All right, parentheses. I'm just following my little formula here. I'm going to go parentheses x. Now, since you guys decided to start at the origin, there is no horizontal shift, right? So technically it's 0 here. If you'd started over here, we would have had horizontal shift. But there's no horizontal shift at all, so just go parentheses, okay? I could have an x minus 0, but that's kind of dumb. And if I take a look at the curve, it doesn't look like there's any vertical shift either. I mean, it's right directly in the middle of the curve, right? So there's no vertical shift either. So that's my equation, for example, 3.
So you don't base your vertical shift off the regular cosine?
Right. We didn't, because what we did is we just flipped it. So it's exactly symmetrical. We didn't move it up and down.
But say on a regular cosine, a 3, and you don't say you have a vertical shift.
Let's turn the page. You're going to see it, because we're going to do a vertical shift next, okay? Okay, turn the page. Okay, now, so if I take a look at this, before I even do anything, okay, watch. So if I look at this one, Jose, this is going to answer your question. So the middle of the curve, let me go ahead and draw again one more time on the side. This is sine, right? This is a cosine. Not a very good drawing, but you know, there's sine, there's cosine. So if I take a look at this sine curve or cosine curve, the middle of the curve is really right about there. Do you guys see that? It's about there. So the whole thing did get moved up, didn't it? The whole curve got bumped up. Do you see a vertical shift this time?
Yes.
So we're going to deal with that last. So first of all, let's go ahead and go through this. So do you want to call it, you can call it you ready? You can call it a negative cosine if you start here. It's kind of hard to find the sine. It really is. But I can then also start here at the top and call it a cosine. So I'm either going to start here at the top and call it a cosine, or start down here and call it a negative cosine. I think I'll start here and call it a cosine. You guys okay? So we're going to have a horizontal shift and a vertical shift. But at least let's start here. Y equals cosine. Let's do this. Okay, now the amplitude. Not quite sure what the amplitude is, but I can do, for my amplitude, I can go my max, which is 1, 2, 3, 4, 5, minus my min, which is a -1 divided by 2, okay? Which is 6 over 2, which is a 3, okay? So my amplitude's 3. And again, if you can't see it, max minus the min divided by 2 will always give you your amplitude, okay? Now the frequency, which is b. So if I need b, it's going to be 2 pi divided by this curve width, okay? So let me see. I could take a journey from here to here, right, and get the full curve. So what is the width of that full curve? From here to here, let's count it. I'm going to go 1, 2, 3, 4, 5, 6. Looks like 7, 8, doesn't it? Looks like 8. So the curve width is 8. So b, which is the frequency, is going to end up being pi force. Okay? So b is pi force. So let's go and put our pi force there. Parentheses. Now, definitely we have a shift. This maximum point got drug away from here because cosine likes to start at the y-axis, right? So we bumped it forward, right? In fact, we bumped forward 1, 2, 3, didn't we? But it's the opposite. It's the opposite. Instead of plus 3, it's an x minus 3, right? It's the opposite. Another ways you could think of, so if to pull it back, we'd have to bring it back 3. How's that? Does that help? To bring it back to the origin, I have to bring it back, subtract 3. Now, it has a vertical shift, so k. And here's another way to find k. K, if you can't figure out that it's been bumped up, looks like it's been bumped up maybe 1, 2, maybe 3. But it's always going to be the minimum plus the amplitude, if you want to find out what k is. The minimum plus the amplitude. So if you have a difficult time figuring out what the vertical shift is, just go to the minimum, which is -1, plus your amplitude, which we said was 3. Actually, I got it wrong. It's 2, isn't it? I counted wrong. So it got bumped up only by 2. So k is 2. So we go plus 2. And this is an equation. There are technically 4 correct ways to do this. I always look for the easiest. You could have called it a sine. You could have called it a negative sign. You could have called it a cosine. You could have called it a negative cosine. And there are 4 correct answers, but I always look for the easiest one, okay?
How do you know when to pick the easiest one?
Great question. For me, the easiest one to find is always cosine. I'll tell you why. It's always easiest to find the max, right? To find the middle, which would be a sine, I mean, it's probably there. There's my minimum, so I could call it a negative cosine. I think that's a sine. This one would have been hard to find the actual middle of this one, right? So the maximum is always easy to identify in a graph. So if you find the maximum, you would be using a cosine, right? So we have 2 choices. We can start here, and I think we can call it a sine, which if we start here and call it a sine, there would be no horizontal shift, right? If I start here and call it a cosine, there is a horizontal shift. So in this case, let's just use the sine. You guys see the sine? How it would be a sine curve. You start here, you go up and take your roller coaster ride. It's the exact same shape here. You go up and take your roller coaster ride. So let's start with y equals sine. Now, what's the amplitude? If you don't see that it's 2, because I see it's 2, because if that's the middle of the curve, if you don't see it's 2, we're going to use our formula. The amplitude is the max. Let's see, 1, 2, 3, 4, 5, 6, 7, minus the min, 1, 2, 3, divided by 2, right? So we get a 4 over 2, which is 2. So my amplitude is 2. Now we need the frequency, b. And to get the frequency, we're going to take 2 pi, always 2 pi, because that's its normal period, and we divide it by the curve width. So let's see, what do I got for a curve width? Let's see if I can take a journey. So if I hop on my roller coaster, looks like I go from here to here, okay? So let's figure out what that is. These go by pi force. Looks like I'm going to right here, okay? Pi force, 2 pi force, 3 pi force, 4 pi force, which is pi. We'll do it again. Pi force, 1 pi force, 2 pi force, 3 pi force, 4 pi force, or pi, okay? So let's figure out what B is. B is the frequency, which is 2 pi divided by the curve width. Well, the curve width is pi, right? Pi's will cancel, right? And so B is 2. So let's put a 2 right there, because that's my frequency, parentheses, okay? X, because that's my X variable. Now, because we decided to make this sine, then there's no horizontal shift, right? So just close it up, 0, right? But there was a vertical shift. In fact, this whole curve got moved up 1, 2, 3, 4, 5. But if you don't see the 5, I've got a little formula right here, right? Where K, which is the vertical shift, is equal to the minimum, which is our 3, plus our amplitude, which is 2, and so K is 5, okay? So I'm going to put my plus 5 here. All right? Now, I've got a worksheet. So, on the worksheet for you, I'm going to go ahead and put this up here, and then we'll stop recording. But on the worksheet, you need to find the equations, right? And then on the graph, you need to listen carefully. So I want you to do all of the equations. I want you to do all, 1 through 8, all, okay? But then I only need you to graph 10 through 14, so you don't need to do 9, 11, and 13, all right? So, ready, set,